Today's lesson is called Arithmetic Sequences. To start, I'd like you to complete the which one doesn't belong activity. Look at the list of numbers that you see in box A, B, C, and D, and find a reason why each item doesn't belong. At this time, pause the video, try the problem, and then resume the video when you're ready to go over the answers. Okay, so which one doesn't belong? There's a reason why all of them wouldn't belong. So you're looking at a list of numbers that are showing different types of patterns. So what's separating them from each other are the patterns that they're showing. So in part A, you have 1, 1, 2, 3, 5, 8. And what's happening is you're adding the two numbers that came before. So the second term came from adding 0 plus the first term. The third number in the list of numbers, 2, came from adding 1 and 1. 3 came from adding 1 and 2. 5 came from adding 2 and 3. And 8 came from adding 3 and 5. So that's what separates it from the rest. B was different from the rest because it was a times pattern. It was the only multiplication pattern in the bunch. C is different because it's adding 2 versus the multiplying of 2. And it's increasing by the same amount every single time. You could have written that down. And D is different from the rest. It's the only one where the numbers are going down, you could have written. Also, you could have specifically said that it's the only subtract 1 pattern in the bunch. Now that you've looked at the list of numbers that you had from your opening little activity, we are going to now actually define arithmetic sequence. And that's what we're going to be working with in this chapter. So we'll start with a definition. An arithmetic sequence is a sequence, which you saw from up above as a list of numbers, where you add or subtract. So it's always going to be an adding or subtracting pattern. So a sequence where you add or subtract the same value. To get from one term to the next. So the key words there is that same value. It's a pattern that is repeated over and over and over again. So since an arithmetic sequence is an adding or subtracting pattern, the next vocabulary word that we need to know is the common difference. So this is going to be the numerical difference, which we will refer to as the letter D, between any two consecutive terms. So up above where it said you add or subtract the same value every time, that same value is called the common difference. So to start looking at this, we're going to identify arithmetic sequences and then practice extending the pattern. So when you're identifying an arithmetic sequence, you're going to determine whether the sequences are arithmetic, and if they are, you're going to identify the common difference. So it's only going to be arithmetic if we see an adding or subtracting pattern and that number is the same every single time. So when I look at number 1, I see 8 went to 6 by subtracting 2, 6 went to 4 by subtracting 2, 4 went to 2 by subtracting 2. It is the same subtracting pattern every single time between all the terms. So yes, this is arithmetic. And since it's arithmetic, we have to identify the common difference, which is represented by the letter D, and we can see there that the common difference was -2. Now in number 2, you see that variables can be involved. So we just need to make sure that the pattern is the same between all terms. So to get from 5x to 6x plus 3, I added an x and I added a 3. To get from 6x plus 3 to 7x plus 6, I added an x and I added 3. To get from 7x plus 6 to 8x plus 9, I added an x and I added 3. So that pattern is the same between all the terms. So yes, this is an arithmetic sequence. Here, the common difference is x plus 3. You're allowed to involve variables in arithmetic sequences. When we look at number 3, 5 became 10 by adding 5. 10 became 20 by adding 10. 20 became 40 by adding 20. So when I look at that, I do not see a common difference. It's not the same value being added every single time. So this is not an arithmetic sequence. In number 4, 1 became 3 by adding 2. 3 became 5 by adding 2. So if I stopped, I would think everything is okay. So that's why you have to check all, because 5 to 8 is adding 3. And now we are not adding the same thing every single time. So this is also not an arithmetic sequence. So you have to be adding or subtracting the same value every single time between all terms. So that's how you would practice, or that's how you would identify if something's an arithmetic sequence. In the next section, continuing the arithmetic sequences. So the directions are, given the arithmetic sequence, find the next 3 terms. So we're going to identify the pattern first. From 9 to 13 would be adding 4. From 13 to 17 is adding 4. From 17 to 21, it's adding 4. So every single time we added 4. So if I continue that pattern, 21 plus 4 would be 25. 25 plus 4 would be 29. And 29 plus 4 would be 33. And that's because our common difference here was 4. In the next one, 5 became 2 by subtracting 3. 2 became negative 1 by subtracting 3. 1 became negative 4 by subtracting 3. So I have a common difference of minus 3 or negative 3 here. So if I continue that pattern, negative 4 take away or minus 3 is negative 7. Negative 7 minus 3 would be negative 10. And negative 10 minus 3 would be negative 13. So you can identify whether it's arithmetic or not, and if it is, you should be able to continue the pattern. Moving on, we want to talk now about how you can actually write a formula for these sequences and use it to answer questions. So the formula for an arithmetic sequence says the nth term, which means you can find any term you want, of an arithmetic sequence can be found using the following formula. So a sub n equals a sub 1 plus d, which was the common difference, times n minus 1. So a sub n is the value of the nth term in the sequence. A sub 1, so when I say sub, I'm saying subscript. You can see how the n is down in the bottom right corner, the 1 is down in the bottom right corner. So we read this a sub n and a sub 1. So a sub n is generic. It's kind of like having, the y equals or the f of x equals when we usually write an equation. And that means we can find any term we want. A sub 1 is actually the value of the first term always. A sub 1 means first term. D, remember, is your common difference. So you're going to take a term and subtract the one that came before it to figure that out. And n is the term's actual location in the sequence. So if someone said the fourth term, that means it's fourth in the list of numbers, which means n is 4. Okay, so that's kind of what the breakdown is of the parts. Now, this formula is on your formula sheet. So in the examples, we will first, in 7 and 8, write the formula for the nth term and then also find a sub 90, which means we're finding the 90th term. We can't find the 90th term doing something like we did where we continue the sequence. I'm not going to list all these numbers out until I get to the 90th one. So the formula is really helpful because we are allowed to jump very quickly to any location in the sequence without having to spend time extending the pattern for who knows how long. So that's the benefit of writing the formula. So in number 7, I see 97, 88, 79, 70. In order to fill in this formula, we always need to find the first term, and we always need to fill in the common difference. The a sub n, the n, and the minus 1 will always stay. So if I want to figure out what is happening, I can take the second term, 88, and subtract the term that came before it. And I would be able to figure out what the common difference is. So 88 take away 97 is negative 9. You also can see that by trying to figure out how this went to here and this went to here and this went to here. But that's what you're doing. 88 minus 97. That means we minus 9, we subtracted 9 this entire time. So now we have the first term. A sub 1 is the first number in the sequence, 97. And now we know the common difference is negative 9. So I have everything I need to write the formula. The generic formula, remember, is a sub n equals a sub 1 plus the common difference times n minus 1. We're going to fill in everything we know. So we know a sub n is generic. We're going to keep it there so that we can find anything we want. The first term is 97 plus the common difference, which was negative 9, and then times n minus 1. So I'm writing it like that this first time so that you see I'm not going to write plus a negative. Adding a negative is the same as subtracting. So my formula is really a sub n equals 97 minus 9 times n minus 1. And I can keep it right like that, following that guideline from the formula above. I just want to make sure you understand when you see this formula and you start to see minus instead of plus, it must be because the common difference is subtracting. And you can see that that minus 9 really is meaning the common difference. Now, I want to show you just in one of these examples how it relates to what we have been doing with functions and mx plus b. This is the first term, second term, third term, fourth term. Normally, when we're writing the equation, we need to know the y-intercept or where it starts, which means we need to know what's across from 0. So if I were to extend the pattern this way, I would have 0, and instead of going forward and subtracting 9, I would go backwards and I would add 9, and I would see that 97 plus 9 is actually 106. So let me show you. Down here, we'll put or. You could actually distribute the negative 9 through the parentheses n minus 1 and get a sub n equals 97 minus 9n plus 9. You would combine the 9 and the 97, and you would get a sub n equals negative 9n plus 106. And it looks very similar to mx plus b. Your rate of change is negative 9. You're going down 9. And you're starting across from 0, that is, at a value at 106. So now you can kind of see why the formula is written the way that it is. And the reason it has the minus 1 is because we never start from 0 with a sequence. We always start with the first term. So this is another way to write that same formula. However, since we have this on the formula sheet and we're working with sequences, this is the one we're going to continue to use. You will see most often. So number 8, the first term of an arithmetic sequence is 23. So this one's just showing you that it can be in words. So that means a sub 1 is 23, and the common difference is 12. So to write the formula, I'm going to go from the basic layout that we know. A sub n equals a sub 1 plus the common difference times n minus 1. Then that means my formula is a sub n equals, the first term was 23, plus 12 is the common difference, times n minus 1. That is my formula. So as long as I know a sub 1 and the common difference, I can write the formula at any time. Then if we look down here, we also want to be able to, well, before we do that, let's take a look. It said write the formula for the nth term and find a sub 90. So we're running out of room here a little bit. I'm just going to work my way over here. If I then want to find the 90th term, I'm going to do a sub 90 equals. I'm going to replace the n with 90. And that means in the formula, I'll also replace the n with 90. So I'll have 97 minus 9 times 90 minus 1. So that would be 97 minus 9 times 90 take away 1 would be 89. So then as I continue to simplify this, I would do negative 9 times the 89 and get negative 801. So equals 97 minus 801. And then if I do 97 minus 801, I get negative 704. So that means that the 90th term is negative 704. So we'll do a sub 90 here, and we'll circle that as our 90th term. And number 8, when I do a sub 90, I would have 23 plus 12 times 90 minus 1, which is equal to 23 plus 12 times 89. 12 times 89 gives you 1,068. And when we add that to 23, we get that a sub 90 is equal to 1,091. So once you write the formula, finding something like the 90th term isn't crazy because you can just substitute it in. You don't extend the pattern. Now, in the next part, we want to look at going backwards. This time, the nth term is 90. This is telling you your output, if you want to think of it kind of that way, what you're getting out of it. You're trying to figure out what n is. What term is it in the list of numbers? Is it the 23rd number? Is it the 42nd number? So that's what you're looking at when you look at this version. So 7 and 8 were going forward. N was 90. You plug it in to find the nth term. Here, I'm telling you the nth term is 90. You're working your way backwards to find out what n is. So a sub n in its entirety is 90. That means that's going to go on the left-hand side of the formula, and we're going to write everything else exactly as it is. As you can see, by doing that, we now have an equation that we can solve. We distribute 3 through, get 90 equals 21 plus 3n minus 3. Combine my 21 and negative 3 to get 90 equals 3n plus 18. I'll subtract the 18 from both sides to see that we have 72 equals 3n. And then I'll divide by 3 in order to get n alone. So that tells me n is equal to 24. So that means if these numbers were all listed out, 90 would be the 24th number in the list. Okay, let's do it again with number 10. Remember, the output, the a sub n, is 90. I want to figure out what number in the list 90 is. Okay, so where's its place in the sequence? So 90 goes in for all of a sub n, and that's equal to 30 plus 0.6n. So here you can see the formula looks more like mx plus b as opposed to number 9 where it's very much in the sequence formula format. So once again, we got to get the variable alone, so we'll subtract 30 from both sides. 0.6n equals 60. We'll divide both sides by 0.6 and get that n is equal to 100. So now I know that 90 is the 100th term in the sequence. Now the last application under using the formula says determine the common difference given non-consecutive, that's the important part, terms. So every other time we've done this, we've had the first, second, third, fourth, or the first, second, third. We've had terms that were in a row. We could easily figure out the common difference. Sometimes they're going to give us the first term, but they might not give us anything other than the third, or the seventh, or the fifth. So what do you do when that happens? So in number 11, the first term is in a sequence is 5. So I know for sure a sub 1 equals 5. But then they tell me the fifth term is 17. So I know the first, then it's blank, 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 blank until I get to the fifth. Okay? So I need to figure out the common difference. What is the common difference here? So in general, remember our formula is a sub n equals a sub 1 plus the common difference times n minus 1. We do know the first term, but we also know the fifth term. So that's what we're actually going to work with. We're going to do a sub 5 because we know the fifth term equals a sub 1 plus the common difference. And we know that since it's a sub 5, the fifth term, we're going to use 5 for n. So now we can fill in a sub 5 equals, well, actually, we're not going to fill in a sub 5. We're going to put what a sub 5 equals, which is 17. So I'm going to put 17 equals a sub 1 is 5 plus d. We don't know the common difference. And then that's really 5 minus 1 is 4. So we can write, instead of d, we can put plus 4d. Or you could distribute d times 5, d times negative 1. Totally up to you how you want to simplify that. Either way, we end up at 17 equals 5 plus 4d. So I'm going to subtract 5 from both sides, get 4d equals 12, and then I would divide by 4 to see that the common difference is 3. So the common difference is 3 is all I needed for my answer here. That's all they wanted to know. What is the common difference? So let's do another one that's similar but asks us for a little bit more. It says, in an arithmetic sequence, a sub 1 is 16. We definitely need that. And this time they gave us a sub 9 equals 40. So that's the ninth term. It says determine a formula. So if we write a sub n equals a sub 1 plus d times n minus 1, how we know we need to set up the formula, remember we have to replace a sub 1 in the common difference. We already have a sub 1, so I can't write this formula unless I find the common difference. So I'm still starting out by looking for d. So we'll do the same thing we did that was similar from before. We have the ninth term, so a sub 9 is going to go there, a sub 1 plus d, and since we're finding a sub 9 and we know the ninth term, n is 9. So now we'll have a sub 9, which is really 40, equals a sub 1, which is 16, plus a common difference that we don't know, times 9 minus 1, which is 8. So once again, you could do 9 minus 1 is 8 and then make it 8d. If you wanted to distribute and do 9d minus d and then combine to get 40 equals 16 plus 8d, you could do that as well. You're going to get the same result either way. So now to get d alone, we're going to subtract 16, get 8d equals 24, and then we would divide by 8 to see that the common difference is 3. So now, though, they didn't ask me for the common difference. I needed to find it so I could write the formula. So the formula is a sub n equals the first term, which is 16, plus 3, which is the common difference, times n minus 1. And that's my formula. So now, for closure, I would like you to try this question on your own and then resume the video to go over the answers. You have a graph of an arithmetic sequence and then the graph of a linear function. I'd like to know, how does the graph of an arithmetic sequence differ from the graph of a linear function? List the differences and use the domain of these functions to explain why these differences make sense. So pause the video, try this closure question, and then resume the video to go over the answers. Now that you tried that on your own, let's talk about it. So I hope that you noticed when you were looking that one of them has a series of points but are not connected, no arrows. The other one is connected arrows. So the graph of an arithmetic sequence is a linear function. So it's still a function. Each input has one output, passes the vertical line test. It has a domain of natural numbers. No fractions or decimals here. Natural is the same as counting numbers. However, when you look at the graph of a linear function, it's also a function, so that's something that they have in common, but they have a domain of all real numbers. We can have fractional values, we can have negatives, so that's how I decided to word the main difference. And that concludes your lesson on arithmetic sequences.